Every day, I ponder my profound interest in transitioning metals. I remember back in the beginning of my junior year when Ms. Almquist taught us about orbitals, and also when we learned about electricity and heat.
Transition metals are a part of the D block, and they're all cations. They're known to conduct electricity and have high melting points and form ions with positive charges. Ions with positive charges in the transition metals are special because it's important to note that they can be found in multiple oxidation states.
Oxidation is just a fancy term for losing electrons. Their malleability and ductility make them ideal for manufacture of any metal-based item. Also, almost all transition metals are solid at room temperature, except for mercury.
They're known for their high ability to withstand stress, and also their high density, melting, and boiling points. They're often good with catalysts and reactions. And as far as I know, iron is the most common transition metal in man-made products.
Iron can be made into steel, which is essential for the construction of my skyscraper in New York and my private yacht. Fun fact, 5% of the Earth's crust is made out of iron. But that's not as awesome as the fact that I'm made out of iron. It's part of the hemoglobin molecule in my bloodstream.
Titanium is one of the most common transition metals next to iron. Titanium alloys are used in artificial body part replacements.
If it weren't for titanium, then I wouldn't have a private helicopter to take me to my skyscraper in New York.
Copper is one of the best electricity conductors of the transition metals, which makes it great for appliances and heating.
Copper is also used in brass instruments, which make up the majority of my orchestra that I conduct on the weekends.
Fun fact, pregnant women need to eat copper-rich foods such as nuts and legumes for proper development of the fetus.
Platinum is popular worldwide for its color, durability, and tarnish resistance. It's used in my sweet new ride.
Automobile catalytic converters, which control hydrocarbon, nitrogen oxide, and carbon monoxide emissions, use platinum as a catalyst for the automobile exhaust systems, which converts these pollutant gases into water and carbon dioxide. Platinum is also used in the medical field.
Yeah, we use platinum in our anti-cancer drugs. And yeah, I'm a doctor on the weekend, so I deal with it all the time. It's also important to note that platinum is grouped together in a category within the transition metals known as the platinum group metals.
The 6 metals in this group are known as ruthenium, rhodium, palladium, osmium, iridium, and platinum. They're well known for their catalytic properties, high temperature characteristics, stable electrical properties, and also their ability to resist wear and tarnish.
I mean, yeah. I guess you could say platinum is great for jewelry. I have an entire collection of platinum and silver. Silver is a great conductor of electricity and also part of a large group of transition metals that have been used around the world for making coins.
As I've already said, the common properties of transition metals are high density and high boiling and melting points. These properties are due to metallic bonding by removing d electrons, leading to molecular attraction, which increases the number of shared electrons.
Transition metals have multiple oxidation states and they're generally good catalysts and reactions. We've already proved this in the micromole rocket lab by using zinc to speed up the reaction process.
This group of elements can be found in the D block on the periodic table. Detached from the transition metals on the periodic table are the inner transition metals, which will be talked about tomorrow.
Iridium is an interesting element because it can only be found outside of Earth, sometimes in comets. But in the rocks found around this time of the dinosaurs, there's a layer of iridium known as the Kaytie boundary that suggests a possible asteroid impact. It was obviously named after me because, you know, I found it.
That's a big fat lie.
It probably is, but there is a layer called the Kaytie boundary.
I'm not sure if I should believe anything you say. You've been lying this entire time, haven't you? Alright, that's it. I quit. I'm done.